Okay. Good evening, everyone. Welcome to this week's session on Arewa Data Science Deep Learning Fellowship. So last week we spoke about tensors and how you could get started with like PyTorch. So this week we'll be looking into details of what is like the PyTorch workflow and how does the end-to-end pipeline of training a model works. So at the end of this session, you will be equipped with ways in which you could understand what the PyTorch workflow is, how you could start from your data pipeline up to like your model deployment. That's one of the key central things we want to achieve. And hopefully at the end of this class, you'll be able to do that on your own. And also then we briefly talk about like the assignment submissions, because it seems like a few people have been having some challenges, and hopefully we can be able to clarify a few things about that after today's class. Okay. So so the thing is, with machine learning is quite really important in like everything as you come across in your daily life, you come to see the importance of machine learning. So one of the important things you need to know is always starts from your data. So data is very key in whatever you do, because you can't build a machine learning model without your data. So, and the thing you should know is how the importance of data stems from how good your data is. When you have a very good data, then you can build a really excellent model. And here we are going to look at one of the key pipelines, which here you can see starts with data. So what this PyTorch workflow wants to show you is how you could start from just your data, but from your data up to like how you could have a fully trained model in which can perform some predictions based on your data. So the very first step in building a machine learning model that you need to have is your data here, which is very, very key. So how the quality of your data determines how well your model is. So after getting your data set, so the next thing is to either build your model from scratch or build an already existing model, so which is commonly known as a pre-trained model. So you might have heard of several pre-trained models, which include ResNet, and which we'll also look in the subsequent lecture. So don't worry about that. And if you already have some background in machine learning, model just captures some representation of your data. So if you want, you can build that from scratch or just build an existing model, which will help you learn from your data that you have in order to make predictions. Then next, what you need to do is to train that model. So it goes through some kind of iteration over and over your data, in which it will learn the patterns of your data in order to predict well data it hasn't seen before. So imagine if you are in the healthcare space, you might have massive data sets of let's say heart diseases in some instance, and your model learns to predict what kind of heart disease that is. Whenever you have a new patient, you don't need to retrain the model again. So it has already understood, the pattern in which that affects heart diseases. So whenever it sees like an image of a patient, so it can easily categorize what kind of heart disease that is. So that's an example of what happens after you fitted your model. Then one important key component is the evaluation, because during the training process, you always want to know how well your model is, so that you know whether your model is improving, if it's learning anything at all, or it's still dumb. So if it's learning increasingly, then you know it's like good, you can just continue training. But if there's no progress in the learning stage, then you know there's something wrong with your model or the way you are training the model. So at the end of the day, you need to check out your either training pipeline or your data, like several other things that might go wrong when training your model. So that's where the evaluation comes in. How well is your model learning at the end of the day, or how well is it predicting at the end of the day? Then if you know how well your model is, if it's bad, then what you need to do next is to improve it through like experimentation. You might change some hyperparameters here and there. So no worries if you don't understand what hyperparameters, you will also come across, always we'll cycle back into that later on. And finally, after you've had like a very good model in which you feel it's good for you and you are like happy about this, then what you need to do next is save your model. We'll come next to what's the importance of saving your model. But this is the general pipeline of PyTorch, or in general, like deep learning. So any kind of model you want to build in the future, will generally follow this particular approach with a few deviations. So even you could see the approach of, let's say, like even models as big as ChatGPT generally follow this particular general approach. So which with like some deviation, but in general, this is how it follows. So when you get to learn about this, it gives you like one of the fundamental concepts you would need to learn when building machine learning or deep learning, very large deep learning models, and to help you in perhaps your academic or career prospects. So it's very good to have like some idea of some like pictorial idea of this, which is like clearly, you can clearly see on your screen here. So you start from the data, you pick a model, fit that model, evaluate how well your model is, then you improve your model during some parameter search, then you save your model at the end of the day. So these are very, very key. So we'll look into each of these in details, which is much more in a more practical way, so that you understand beyond the theoretical discussions we've had, so that you could see how you could easily implement that with PyTorch. So as always, I'll skip over some things. These are things you could easily read so that we can focus on what's more important, and we'll explain more on that and go into deeper details. So as always, when starting out with any, let's say, machine learning project, you import the necessary libraries you need. So here, the main key library we will be using is like Torch, as we have discussed earlier. So we'll be importing what's important. So we import Torch, and we import like the module called NN. So NN is a module that holds all the things you need for building neural networks. So think about it like a toolbox. So a toolbox that holds the necessary tools for you to build your model. So you can call some methods or some or some attributes from NN, which will help you like build your neural network model, which you will see in the coming cells. So I can see we've just imported our Torch. It has version 2.5.1 with CUDA enabled with that 12.1. So one of the first things we will need to do is load our data. So as we have talked about last week, your data can be anything. So it can be images, it can be text, it can be audio, it can be video. So it can be anything. But one thing you should know is your computers cannot understand these modalities on its own. What your computers understand is numbers. So any kind of model you get to build in the future, your computer will only understand numbers. So you have to find a way to translate all these modalities into numbers. And that's where your tensors, in which you've learned last week, comes in. So with tensors, you transform it into a good representation in which your computer can easily utilize to build like very good models. So yeah, so don't worry about this. We'll get into, when we get into computer vision, you see how images can be translated into numbers. That will be easy for computers to understand at the end of the day. So here, just have an idea that all your data needs to be converted to numbers so that you can build or train that machine learning model based on that. Because your machine learning model is like a stack of numbers also. So it's like numbers interact with numbers to generate numbers, which will help you in your prediction at the end of the day. So also feel free to ask questions either on the chat or towards the end of the session. I'll be very happy to answer your questions. So one of the things we'll be looking at is we will be building a regression model using PyTorch. I don't know if you still remember a regression model. So regression model helps you to build a relationship between some variables and make some predictions. So imagine, let's say you have here on your x-axis, let's say you have, let me see. Yeah, let's say you have maybe the height of a person, for instance, and here you have the age of a person. So here, ideally, or not really ideally, so you can guess like if the height of a person is not so much, maybe you can guess his age to be perhaps 8. So depending on the height of a person, you can predict his age. So here, what you can do is perhaps build some, and you have like some outliers in some sense. So here, what you can do is build a linear regression model, which can help you predict this. So you can have like some kind of linear line that best estimates this kind of behavior, but this is not like perfect in some way. So, but So what machine learning models helps you to do is, how can you get this? So this is like your model. So what we'll be looking at is like a linear regression model, how we can build that from PyTorch. So if you remember, like equation of straight line, which is called mx plus b. So we'll be like modeling this equation from using PyTorch. Yes, I think there's a comment. Okay, so it's not related to this. So what we'll be modeling essentially in this particular class, just to look at like how the workflows happen, is modeling this particular equation, your mx plus b, using PyTorch, just so that you could have a feel of how that particular. But in the subsequent lectures, we'll go over like much more bigger things, and you'll see the power of PyTorch at the end of the day in modeling distance. Yeah, so that's it for a recap for linear regression. You have your weight and you have your bias. So here, usually we call it slope, and here you have maybe intercept. But when you come to the machine learning or deep learning environment, so here is known as your weight, and this is your bias, but they're essentially the same thing. They're the same idea anywhere you go, so it's the same thing. So yes. So here, what we need to do is generate some random data. So, or generate some data set that has some relationship. And at the end of the day, what we want to do is build a machine learning model that would learn to predict this relationship between X and Y. And that relationship here is like, it has like a weight and your bias, but your machine learning model will not know this. So you want your model, train your model to learn the relationship between X and Y. So let me just run this and explain the goal again. So we have some data and some label here, Y. And there is a relationship between your data and your model. So what we want to do, okay, there's a question for Octavia. Just 1 minute, I will get back to you in a minute. So ideally here, maybe there is like a function here, like based on your X, so you can have like a Y, but in general, you don't have this, because not everything can be explicitly like defined by some formula. So that's where your deep learning models comes in. So with your deep learning model, you can have X and you have a black box model, which can help you predict Y at the end of the day. So your input comes in from your X here, your X, then it goes to your, like the model you have, which you'll be using PyTorch to build here, and you learn to predict Y here, but it doesn't know the relationship between X and your Y here. So here, what we are doing here for the very first start is to create a data set here of your X and your Y, and we try to see how your model can like learn the relationship between your X and your Y. Yes, there's a question from Utebi Abasi, please.
Okay, all right. So, thank you, sir. Before you start the modeling, I
Utebi
wanted to
Abasi,
know.
do you have a question? You can unmute and ask your question.
Yes, yes.
Okay, so I guess we'll continue then.
I'm trying. Yeah, can you hear me? Hello, can you hear me?
Yes. So after, let's say you have your data, this is just a sample data which you created, but in real world, you have some data you can either get your data from Kaggle or some existing data somewhere else, and you use that data to train your model. But here we are just creating some data sets here, and we know the relationship of that data here. So don't worry about this. We'll get more into details about like data or how you could get your data and how you could train. Then one key concept is when you have your data, how can you like partition this data so that your machine learning model will learn from data and to help you evaluate how good your model is. So there are three partitions you might need to make when trying to train your model or trying to evaluate your model on a data set. So think about it like in the manner in which you have, let's see, your data here. So what happens is, let's say you have probably, let's say some images here. Let's say you have 5 images in this instance. So what you want to do is to train your model based on these images and learn and also understand how well your model is doing. So you can partition it in 3 ways or 2 ways. Either, let's see, what we have here, you call it like train set or test set, and you have what we also call validation set. Don't worry, I'll explain it to you now. So train set means the data you use in training your model. Assuming this is the model we want to build, then we can specify some part of the data here, and we use it to train the model here. So that's what your model says at the end of the day. So that's what your model will learn the representation of. By the end of, and again, what you, after training your model, you want, or within the process of training your model, you want to evaluate how well your model is. So that's where this two comes in, where you have your validation test, and your validation set and your test set. So they help you evaluate your model based on examples they have not seen before. So this is very key, because after training your model on like very large data, there is the high chance your model will not see that data again in the real world. So imagine the case we talked about in the healthcare sector, in which perhaps you have a data bank of several images and your model learns to predict the patterns of heart diseases and classify them accurately. So there is likely a chance in which your model will see an example of a patient with heart disease it has never seen before. So you want your model to be very robust in such predictions. So that's why from your data set, you kind of simulate the scenario in which your model has not seen some data. So that's why you split your data. So here, what we can do here is, for this very first set, we can split it into, we can call it a training set. So this is the set we use, or some partition of your data in which we use to train a model. So our model has seen the data. So yeah, so ideally we won't want to use this data to evaluate the model, because it's more of like cheating. So imagine in a class where you give, maybe you can give an example, you can give an exercise to a student in class, and imagine giving that same exercise in exams. So it might not be like the ideal way to test the knowledge of the student. So you want to give it something different to evaluate how well it has learned from that. So that's like just an analogy. So what you can do next is, after you've trained this on, let's say, this first two data sets of these first two images, then you can have a maybe validation set here. Let's call it validation set. So validation set happens within training. So when you are training the model, maybe you can train it several times, then you have like the validation set, which tells you within training that, yes, this model is improving. Yeah, it's getting better. That's within training. So the model still says that within training process. So it just helps you to calibrate your model. Maybe if your model is not doing well on the evaluation set, then you can, on the validation set, then you can like tune some hyperparameters for your models just so that it improves at the end of the day. Then finally, what you have here is like the test set. The test set is like a partition of the data set in which your model would not be trained upon or has no idea entirely upon. So it just happens after you fully train your model on the training data set, and you've like kind of change some hyperparameters of some settings of the model with the validation set. Then finally you finish, you have a fully trained model. Then what you want to do is to test it based on the test set. So it helps you understand, so it helps you like kind of evaluate how truly your model has learned from examples it has not seen before. So there's a comment from Utebe Abasi. So I wanted to know which type of ML model we are building. Is it supervised or unsupervised? So here we are actually building a supervised learning model, but that's not really essential here. So it's just to get the general concept or workflow of machine learning. So at the end of the day, you would come to see like everything applies, either supervised or unsupervised learning. So everything applies, but most part of this class will be dealing with supervised learning. So you can either apply unsupervised learning to your course project at the end of the day. So always feel free. Yes, but this applies to supervised and unsupervised learning. But here we are just focused on supervised learning, but the general concept of workflow applies to both. Yes, thank you. So that's how like the partitioning of data sets happened. So hope that is clear, but if there are any challenges, just let me know. So you come to see this later on when you try to train like really like models that you want them to work well for you or to be very efficient and robust to new data sets. So you have to partition your model in a very, you have to partition the data set in which you have your training set and your test set. So most times people don't usually use validation set depending on what you want to do. So it has, so typically what you should what you need to consider, your training data should be larger than your other sets. So ideally, what you might want to target is, let's say 60 to 80% of your entire data should be your training data set, then the rest should be your test data set. So if you want, you can have your validation set, which is also good to consider. Then you can have your test set, which emulate like real world scenario of data set or data your model has not seen while training. So feel free to ask questions. So happy to answer them. So that's how like splitting of data happens. So here just does a split for you. So I won't go deep into this. These are just operations you have when dealing with PyTorch, which we've covered last week. Then, yeah, so this, I won't go over this. So let me just skip to the more important part, which is like building your model. So right now you have your data. Then what you want to do is have that model which you want to learn. So what we want to do here is to build a linear regression model. Then I will explain how this model works. Don't worry about the details. So in building a model, one important component you need is this nn.model. So nn.model is an existing class that is created by PyTorch. So think about this class as a construction company. So it has all the necessary materials you need to build. Imagine you want to build a house, which is the model you want to build. And think of this nn.model as like a construction company, which kind of takes in all the information you want about the house and helps you construct it and build it for you at the end of the day. So I think that's your NN model. So it has the essential tools for you to build your neural network model. So what we want to do is to inherit from that particular class. So if you remember from your Python in which you've done classes, then you can inherit from another class. So here you inherit all the properties that class has and the methods and attributes and everything. So that's what we are doing here. You want to build a model, but you want to use the existing tools that are existing in nn.model here. So what we have here is like just typically our module name, our model name, which is linear regression. So in our model class, we have two, let's say, methods. One is the init method. So if you remember with the init method, it gets initialized anytime you call a class. So when I call the class linear regression, so it always immediately I call it, it always runs this for me, everything we need. Don't worry, I'll go into the details of what's in the init method. So whenever you call that class, so the first thing it does is it initializes the class with all these attributes here. So remember we said we want to build a linear regression model, which is, let's see, mx plus b, in which our m here is the weight and b here is the, let's say, bias here. So the first thing we want to create is this weight here, which is like our m here. So what we want to create m here. So if you remember, this m here will change depending on the value. So it can have different range of values, and we want to learn the best m or the best b, which will help us predict from x to y here. So that's what we want to do. So to do that, since we know our m changes or our weight changes, so we want to create what we call a parameter. So parameter just means a variable, but a variable that will change in time. So after your model learns and learns over and over again. So here, after declaring what we want to create as nn.parameter, we want to initialize it. So in initializing it, as you can initialize it with any, as a tensor. So a tensor of any size. But here, what we specify is we want it to be a tensor with tensor size of 1. And also want it to have a D type of float and requires grad. So I would highlight this over again. So what we want this parameter to hold is a tensor, which holds only one value. And that value is float 32, which is it's a decimal point number. And it should be able to accept gradients, or it should require gradients. So why this is important is, which we will come to see later, is when building your model or when training your model, so you want to improve on that model. And that model, to improve on that model, you need to learn about gradients, which helps you like improve on the model, which adequately adjusts the parameters of the model. So to explain gradients, let me see. So to explain gradients, let's see, at first, let's say for an input of 3 and a y of 4. So let's say you pass this x to your model. Let's say this is the model you are building and it predicts 5. But this is not what we want, because what the actual value is 4 and it's predicting 5. Then your model, so it's possible to see like this. So it's easy to see like this 5 deviates from 4. Then what you can do is like to calculate some kind of gradient and it will have like some value. Let's see, let's say 0.5 in this instance. So when you have this value, you can use it to update your model, which helps to improve your model. So that's why we have required grads here, so that it accepts gradient, so that it can change at any point in time. So similarly, the same thing goes for self.bias, like similar explanation. You have a parameter that stores some values and it's float 32 and requires grad. That means it can change with time. So that's for initialization. When you call the model initially, then it initializes the class of the model with your weight and your bias with some random value. So we talked about random.n. So it's like it initialized with some random value within the normal distribution. So finally, okay, let me just clear this. So after initializing your model here, so what you would want to do next is forward. So forward just means to say what happens when an input comes into your model. So remember we said you have an X coming in and you have your model here. Then you want it to predict some values. So think about this as your forward is here is what your model does with this X that is coming in here. So this forward here is, let's say, essentially this here. So what happens? Will it do some operations, and what will that operations be? So remember, our goal initially is to learn to predict some relationship mx plus b here. So the forward here will capture this relationship. As you can see, we have weight times x, then plus the bias. So that's what we have in your forward. So your forward just essentially captures the relationship. If an input comes into your model, what happens? What does it do after that? So for us, we are modeling linear regression, which is mx plus b. So that's what our forward would do. So in much more complex scenarios in which you are dealing with complex architectures, so all the logic of the architecture goes in your forward. So you will come to see when we deal with some computer vision models that had to do with like probably ResNet and AlexNet, so which have some slightly more complex structures. So all the complexity goes into the forward method. So hope that's clear, but don't worry, if there are any confusions, we'll get back to it in time. So that's how you create your basic neural network that has, or your basic PyTorch model, in this case, for linear regression. So I will slightly speed up a bit. So we've explained most of this, and just feel free to also read them. And if you have any questions, I'm available on Discord, then please reach out and we're happy to help. So here, what we are doing here is we've created a class of the model. So as you know, with the class, it's more of like a blueprint. Anyone can use it, or you can create it multiple times. So here, what we want to do is create an instance of that class, which is, then here we call the name we had linear regression and store it as model. So here we've created an instance of that model, and at any point in time, you can always use that model. So if you want to check what's in that model, you can check it, or what are the parameters of that model. So you can check it by calling model.parameters. So here you see what are the parameters. Remember, just here, we created some parameters within the model. So here your model stores these parameters, and perhaps you are doing some, maybe later on after building your model, you want to see what's the actual parameters it has learned, then you can call model.parameters, which holds the values of your parameters. So as you can see, we have two parameters, which is tensor and tensor, which is like the two tensors we created, the one for the weight and one for the bias. So it's stored in the parameters method. So if you have multiple parameters, it will also be captured there. So you can use it at any point in time. Yes, so that's one way to access the internal state of your model. Then next, one other thing you could do is check out the state dict. So as you can see, state dict So yeah, so state dict also kind of outputs what's the output of your model. So it has like tensors and tensors. As you can see, it's like all the same, 0.336, all the same. But quick question for the audience. What do you think is the difference between the parameters we have here and the state dict? You can just type in the chat. So if you want, you can unmute. So what is the visible difference, can you say, is between the parameters method and the state dict method? Can you see any difference? But if you want to unmute and say it out loud, feel free to unmute. Let me check the chat.
Yeah, I think the state dict
Any difference
has a name. It names the parameters.
between the parameters and state dict? Yeah, there's a comment by Sani Aji. State dict has the weight and the bias plus tensors. Then, yeah, then there's a comment by Ibrahim. State dict gives them as a dictionary, which is like very much correct. Thank you so much for the answers. So as you can see, they hold the same thing here, but here, so one thing you can notice is in the parameters here, you just get a list and very little information of what is where or where is where. So it's just like you just get the tensors just given to you. But if you want much more like important information about like what is what or where is where stored or what holds what tensor, then you use take dict here, because you can in here it's essentially a dictionary in state dict. So it holds the weight. So it's telling you weight has a value of this and bias has a value of this. So it gives you like much more important information, but all have their purposes. So at the end of the day, so you come to see where state dict is important. So parameter is important when you want to do like some optimization or just learn from the model, just like you do your forward pass. So you just use the parameters and go. Then state dict is important when you want to store the model for later use. So thanks so much for the comments. So here we've created a model. So what next we want to do? We want to try out how can we like test the model? Not really test the model. So how can we pass an input to the model and get an output? So what we would want to do is, so in general, if you want to test your model, so you want to use torch.inference, it just tells it that you are not training the model. So it's like you are doing an inference. So there's a difference. When training the model, your model is learning from that data. And when doing inference, there's no learning happening. So it's just, the model is just there, static. So that's what we call inference. So with this width here, it's like a context manager telling your, or telling your like Python that there is no training happening. So what you want to do is just inference. You don't want to change anything about the model. Then you can see we have the model here and we pass it an input called xtest. So what happens here is when we pass xtest to the model here, so it goes into the forward method that we created previously and it gets an output for us. Then we'll see what that output is. Yeah. So here you can see it has, so here you can see, so we predicted some value, which is y pred, and we can see it has printed out like the predictions we made. But mind you, these predictions will not be valid because we've not trained the model. So it's based on some randomly initialized values. So don't expect any good performance from your model. So that's it. So I'll just briefly skip a few things, which I believe when you read, you will get to maybe understand them better, but I'm not skipping anything you won't understand. So I'm just going to the key things so that to explain them better for you. Yes, so here we have like a model we want to build and train upon. So at the end of the day, when training your model, you want to, as we spoke about, we want to evaluate the model, how well it is so that we can make it better. So that's where we need a loss function. Yes, there's comment. Okay, let me just briefly, okay, there's a comment by explanation on inference. We'll come towards that towards the end of the class. And there's a comment also on gradient descent. We'll also come towards that at the end of class, but just remind me if we miss that. So yes, so you want to learn how well your model is predicting. So there's, yeah, so think about, So you have a model which you want to train, and at the end of the day, you want to evaluate how well it is. So there are plenty metrics or a number of metrics you could use to evaluate the model. So, but one important one you come across today and every other day, if you continue to do deep learning, is like what we call the cost function. So cost function. So think about it this way. Let's say you have, let me see. So let's say you are building this really nice fancy machine learning model, in which you want to learn a presentation from your X to your Y. Then what happens? Let's say you pass in the same X, yeah, and oops, yeah, just 1 minute. Yeah, let's say you are building a really fancy machine learning model here, which hopefully will help us understand the relationship between your X and your Y. And let's say you pass in X to the model, but it predicts a certain value for you, like Y prime. But that Y prime, you're not too sure how, whether it equates to like the Y. Are they the same thing? Is this and this, are they equal? So what you want to do is like to close the gap so that your model predicts as much as close as possible to the actual value. But you need to find a way to how you could measure how close your model is or how correct is your model. So that's where cost function happens. So think about it this way. Let's say you are assuming, so let's see this one. Oops. So assuming, okay, assuming 1 minute. Okay. Yes. So assuming, let's see. Yeah, just assume this is like a map of Nigeria. Sorry, it's like horrible for now. So you find yourself in, let's say you're in Nigeria, and particularly let's say you are in Kaduna and you want to travel to Lagos. You want to travel to Lagos. So what happens is you start out here from Kaduna and you want to go to Lagos, but you don't have, let's say you don't have the fancy Google Maps as you have in this case, but you're allowed to start out in any direction, but you have the map. So the map will tell you how well you are moving or how far away you are or how close you are. So let's say you start moving towards the north here. So you start moving towards the north here. And as you move towards the north, you can visibly see on your map, you're moving away from Lagos. So that's essentially how the loss function works. So it tells you, hey, look, you're not going the right direction. It's better we move this way, or you're deviating from what's possible. So that's how the loss function happens, or it works. That's intuitively. Then at the end of the day, what you want to do is to navigate much more properly towards like Lagos. So how would you do that? So you do that using your optimizer. So you think about the optimizer as a steering wheel to guide your model to a much more better direction. So as you continuously move towards your journey from Kaduna to Lagos, then you have the map which tells you you are moving towards the wrong direction, you are deviating, or you are slightly off course. Then you have like the optimizer, which serves as a steering wheel to help you navigate better until you reach as close as possible to Lagos, which is your destination. So when you are close as possible to Lagos, you know, or at least you are satisfied, you've reached some of your achievable goals at the end of the day. Then we'll look into how that you can include this in your workflow. So it's nothing too complex. As we said, PyTorch is an API. It has everything inbuilt for you. Then we'll quickly explain that. Then, yeah, I think we'll spend much time in the training loop of PyTorch, because that's what's important. At the end of the day, on subsequent classes, that's what's very key. And you're also in your career also. Yes. So I just hope this explanation is okay. But at the end of the day, just feel free to ask questions towards the end of class. So 1 minute, let me just stop sharing and share again. Okay. So there are several loss functions you can think about. So one is what we call like the mean absolute error. So what it does is, So what it does essentially is, let's say you have your, let's say, true value. I suppose then this is like your predicted value, which is, let's say, y prime. So your loss here becomes, the absolute value of y minus y prime. So which we call like the L1 loss. So easily think about it as, yeah, so it's just like, what's the difference? So imagine you want to pay someone, or someone is selling a goods for you for 200 naira and you paid him 300 naira. So what's the difference between that? Or how much have you paid in surplus? That's like 100 naira. So just think about it that way. So, but here you have the absolute value. So so absolute value means there are no negative, everything is just positive. So even negative values, you treat them as positive. So that's where your L1, that's where you have your L1 loss. Then at the end of the day, you have your optimizer. So here we're using stochastic gradient optimizer. Don't worry about that. We'll come into details about that, just for you to get an idea of how this workflow happens. Just take it as it is, optimizer as a steering wheel to help you guide your model better. So yes. So here what you have, you initialize them and you run them. So let me just share again. So I can't seem to clear this away. Yes. So let's just run this. And, so here we've created our loss function and we have our optimizer. So this is one of the most important part of the lecture. Then we'll spend a few time here, then more time here, then briefly talked about saving and loading models. So what you want to do at the end of the day, when you have your data and you have your model, so it's your model to learn from that data, then you want your model to look at the data and see what it can learn from the data. So one key thing to look at here is this epoch or epochs. So epochs means how many times you want your model to look at your training data. So you want it to look at the same data 100 times. So that's where you set your epoch. So here we have an epoch of 100. So we want it to look through our training data 100 times. So in our earlier example where we said we have 5 images. So here our model will look at those 5 images 100 times. So it looks at the first set of 5 images, that's the one epoch. Then when it looks at it again, okay, let's say our training set has 5 images. So it looks at like the 5 images. So that's one epoch. So here we want it to look at the training or the 5 images 100 times. So over and over and over again until it has learned some representation about that image. So here what happens is we are just storing some values, which is the loss and some like epoch counts. And yeah, so what happens when training an epoch? So what we are doing here is to go over the epoch. So epoch 1, epoch 2, epoch 3. So what happens? So first, what we want to do is set our model to train. So we want to tell our training, or in our training, we want to state it that now what we are doing is training. So feel free to optimize the model or improve on the model. So that's one. So the next thing is we want to do a forward pass. So the forward pass, what we do is pass an input and you get a prediction at the end of the day. So what you essentially have here is a prediction of the model, but you don't know how good it is yet, but your model has predicted. So that's one thing to do. Then if you want to know how well it has predicted, then we call our loss function, in which we have created just previous in the previous cell. Then we pass in the actual value it's supposed to have and the predicted value. Then with the loss function, tell you how near or how close or how far away your model is. So based on that, your model will learn to improve. So in your loss here, you just have, let's say, one numerical value. Maybe it can be maybe 8.5, depending on what kind of loss it can be. So if it tells you it is 0, that means your prediction and the actual value are totally the same. So perhaps your model doesn't need to improve much. So it has learned to predict like perfectly, but it's a bit tricky when it goes to 0. So you have to be like careful there to make sure your model has not memorized anything. So that's loss. So once you have gotten loss, so what will you do next? Then we move over our steering wheel. So what we want to do again is optimizer does 0 grad. So what 0 grad does is you want to clear out all the weights. So let's say you have already started driving your car to your destination, Lagos. So what you want to make sure is you are not using the past information you've had all along. So you want to clear out all those information because you have a new direction from the map where you should go. So first you want to clear out all your maybe existing assumptions or all the weights because you've used them before now. So you want to clear it out so that you could use something new. So after you've done that, you clear out the gradients that are held within the optimizer. Then you want to do like some backward. So what happens in backward means you kind of calculate what direction your model should go or how you could change your model so that you can improve better. So don't worry, we'll get into what backward is and you get more idea about it. So just think about backward. It's more of calculating the gradients, which will help you improve your model better. So after you've gotten, so here's to calculate gradients. So like we said, you have mx plus b, then you can calculate, you can get like the gradients b and x, because at the end of the day, what you want to do is to change these values so that you can predict x to y accurately. So these are your gradients. So what this is doing essentially is here, you are calculating the gradient based on these methods. So mathematically, it's like a bit much more cumbersome to go into, but as you said, it's nicer and easier with the Torch API. Then you just call it and it does everything for you effortlessly. So you don't need to worry about that. So after you had your backward, what you want to do next is update your model parameters. So assuming we've gotten our gradients, delta W, delta B, don't worry too much about this. So we want to have a new M. You can say maybe M plus delta M. So this comes, where is it? Here in the step. So it's telling it, hey, I have a new direction based on my steering wheel. Let's move towards like more south or much more or southeast or any direction you want to go. So that's where step happens and your model updates and it gets better in time. So here, that's like one training pass. And if you want, you can do like some evaluation. So evaluation, as we said, is, or inference is more of like try it on the test data, but you're not training, you're not changing the parameters of the model. So what you want to do is set the model in eval mode. Then when you set it to eval mode, then you call torch.inference. So in eval mode here, what happens is you tell all the model parameters is, yeah, maybe we won't go deep into this for now. So just get the idea. So yeah, just get the idea. Maybe in the next class, we talk into this in detail. Then here, what we do is evaluation. So evaluation is, I've trained on my train data. So how does it happen, or what's happening with my test data? Is it still as good as it is on the data set it has not seen before? So that's what happened in evaluation. So let's just run this and see if our model is actually improving or not. So I'm very sure when you look at the notebook, so I'm just explaining some key ideas that are important for you to understand, so that when you look at the notebook, you have much better intuition of what's happening on the line. But if you have any concerns or challenges, feel free to message. So what you can see is your model starts out as a very high loss, let's say 0.3, and ends at 0.027. So the lower the loss, the better. So it's telling you are doing a good job and it's heading towards the direction. That's for training data. Also, you want to look at the test data. It started at 0.48 and it goes down to 0.6. So that means it has improved, because remember we said like for mean absolute error, which is being used here, 0 means perfect prediction. Okay, prediction. Then any other value means like it deviates. So the larger the value, the larger the deviation of your prediction. So that's how you can interpret this loss. So there are different laws, and different laws have different ways of interpreting them. But essentially for this, the lower, the better. Yes. Then you can also like print what happens. So as you can see, like for each epoch, as the very first beginning, you have like higher loss. So with time, you can see your model is learning based on training data. Then here on the data it has not seen. So it's also like improving with time. Yes. So that's majorly it for model training. So as we said, there's stake date, which we talked about. So finally, we'll just briefly touch model saving. So here you built your model, a really impressive model to do some predictions. So perhaps heart disease, or let's see some protein prediction, a really fancy model, or you build the next ChatGPT-6. So you want to save the model at the end of the day so that other people will use. Because right now, all the things you'll be doing is in memory. So everything is on your device or on the GPU memory. So, but let's see, you want to use it for in the later sense, or you want to deploy it, you have to save it to dict. So that's where saving comes in. So I'll briefly skip over this because we talked about inference, and I'm very sure when you look at it, you would understand it. So you need to save your model. So it happens also, it's important when you want to build like or train really large model. So at the end of the day, you train perhaps for 1 month or 3 months. So, and anything can happen. So you want to be checkpointing at the end of the day. So that's why it's important to save your model. So what we have is we have state dicts. So that's the state dict we talked about. It's very important. So if you want to save your PyTorch model, what you only call is torch.save, and you pass in the state dict. Remember, the state dict is a dictionary that holds the structure of your model, including the tensors it have. Then it uses that to save your model and locally on your computer. So it's either you can either download it or share it with a friend to use, or deploy it on some fancy UI for anyone to use. So what you want to do is to save your model is you call torch.save, and you pass in the state dict object we talked about, then a path where it will be saved, which any path you want it to be saved, then it saves it to that path. So as you can see here, we've saved this to Torch workflow model. So at any point in time, I can check and I will see it's saved there. So here it's saved there as it's persisted to disk, so I can use it anytime. If I want, I can download and do anything I want with it. So that's majorly for saving. So also what you can do is to load your model after saving it. So what you want to do is torch.load, just similar way you use torch.save, then you can use torch.load and much more fancy approaches to do the loading. Yeah, so I would say that's majorly it for this particular session. So in this session, so I'll just pick the question. So feel free to ask any other questions you have. And let me see. So I'll just answer a few so that we can, for the interest of time. But when you go through the notebook, I'm very sure the rest are much more easy to follow. So we talked about most of the crucial concepts here. So inference. So someone talked up, Shamsu was asking a question about inference. So what happens is when you train a model, as we said, you want to train a model so inference just means using the model again, but you are not training it. So anyone is using it. So think about this like, let's see, the ChatGPT you are using currently. So you are inferencing the model. You are not training the model because you are giving it an input that's giving you an output. So no training is happening. So that's it. So, but if you are training, that means your model is learning from the data, you are feeding it over and over again. So inference happens when perhaps you finish training. So, and the model doesn't need to learn anything. So just using the model is called inference. So there's a question on gradient descent. So gradient descent simply means, so gradient descent, so I would just briefly explain gradient descent, but we'll look key into it in the next lecture or subsequent lecture. So gradient descent just simply means it's a way to look at how your model learns. So imagine you have this landscape of perhaps, let's see your loss, and let's see the weight of your model. And you start at a very high loss here. So, and with time, you want to improve that loss. Let's see, the loss landscape will likely be something like this with time. So these are like different values of perhaps your model. So gradient descent means in what direction, but this is very simplistic. In what direction should your model parameters move in order to get the most minimum loss as possible? So that's gradient descent. So how can you improve your model based on what it has predicted? You remember when we talked about like the loss? So you have a loss, it shows you how far away your model is from predicting the right value. Then with gradient descent, it helps you to adjust the model parameters or how well you should go. So here we can go a bit in this direction So the direction we go, the lower, the better. So that's gradient. That's like intuitive, but we'll go deeper into it in the subsequent lecture. Then there's a question from Abdul Ahmad. At what stage of training the model are we to use the loss function for measuring how good the model is? What is the best evaluation matrix are we to use if we are developing a model that classify images? Yes, so your loss function, you will use it at every point in your training the model, because you want to evaluate after you predict like every batch or epoch. So depending, let's say you are doing some, yeah, so after you do any prediction, so you want to evaluate how well it is, because that's the only way a model can improve. And so what is the evaluation metrics? He also acts the evaluation metrics to classify images. So with classification of images, or in general, look at it like classification in general, what you want to do is cross entropy loss. So there are several other like losses you can use. With, let's say, binary cross entropy loss, you are classifying two, let's say, images. Let's say you are predicting between class and dog. Then you can have the general cross entropy loss, in which you can have like several classes. So that's one. Yes. So there is a question from, okay, yes. Thank you very much. There's an answer from Khadija Simon. Thank you so much. Yeah, cross entropy, yes. And yeah, so there's a question from Tenimu. So please, we just add like 10 minutes for the questions and briefly go on how you could submit. Thank you so much, but feel free to exit if you want. So let's see, what's the best epoch to use? So there's a question from Tenimu Abdullahi. What's the best number of epoch to use? So that depends on you, the machine learning developer. So over the years, or as you continue to go, you try to see, or you try to have some intuition of what's the number of epoch you should use. But you could start out small, for instance, or yeah, you could start out small and see how the model improves. So maybe you can set it to 10, and maybe after 10 or after the 5 epoch, you could see my model is not improving as I want to, then you can go really, really large. So if you have the number of compute, but there's no like definitive way you could see like, I need to set this 20 epoch and everything is fine. So you just do that by experimentation. So that's where, when you evaluate and you see the loss, then you see, hey, I need more epoch. This will not be good for me, so I need to do more. Then, so there is a question from Dahiru. So is there an acceptable range for the loss function? So I wouldn't say there is an acceptable range. So what you want to do is to make sure you have the lowest loss function as possible. So, and it depends on the problem you are solving. So for some easy problem like this, you can see the loss function goes to like 0 point something, which is like really, really low, and it's okay. So if you are, so you have to evaluate several things like the training loss, the test loss, so that you don't overfit or underfit the model. So you have to make some trade-offs at the end of the day. Then you have to do like several hyperparameter search, then pick the best one you have or the best one you can work with. Yes, but there's no, I can't say, but it should be as slow as possible. And you have to make sure the training loss and the test loss do not kind of counter each other. Maybe the training loss is too low and the test loss is too high. So it defeats the purpose, because when a test example comes in, it's difficult to work with that. Then quickly, there is a question from, so isn't Y output fed to a nonlinear sigmoid and a ReLU? There's a question from Ibrahim about perhaps why we didn't consider some nonlinearity in this case. So here, in this example, what we are trying to do is to model a logistic, not a logistic, a linear regression. So, but when subsequently you see where we'll use activation functions, and you see like the beauty of activation function and get to appreciate it better, because it helps to improve your model. But here we are just building a linear class or a linear model. So that's why we didn't use ReLU, but don't worry, we'll come into that. So yes, there's a comment from Aliu on the gradients, which thank you so much for the answer. So what is the best way of selecting an algorithm from Faisal? So I would say, I think in this, you have to do a number of experimentation. Let's say you have to understand what problem you are dealing with. Is it an image problem? So if it's an image problem, you want to go with like convolutional neural network. So if it's a classification, let's say if it's a classification problem, so you want your model to predict, so it helps you understand what loss you want to use at the end of the day. So first, you will need to understand what problem you are solving, like frame it in the way, let's say, I'm solving a problem with classification. So you know all your predictions have to be like classification based. You have to like, don't worry, we'll talk about classification in the next lecture, so you have an idea of it. So understanding the problem you're solving helps a lot, and also probably checking online. You have like very valuable resources online, either on Reddit or lots of people. So maybe just describe a problem and you could get some like high level ideas of what you can use, and you can try them out and see. So you can also, I think one key thing is also to look at, I think is it papers with code? So if you are dealing with some particular problem, so you can see some benchmarks in which you can see which models perform best or which approaches perform best, and you can do with it. So, but for here, you can start with the basic things as we are doing now. So over time, you get a feeling or some understanding or some intuition of which of the models would be, or which of the algorithms would be helpful for you over the years. So I think that's majorly the questions. So just for the sake of time, if you have any comments, say I'm on Discord. So just briefly, let me just talk about the submission in less than 5 minutes. So here, I understand like there are a few challenges with the submission. So our expectations ideally is for you to like fork the Arewa deep learning repo. So once you do that, and you can do that by this. So, okay, so this is my code. So unfortunately you can't, okay, let me see. Okay, I think I have forked it already, so I don't think you can. Yeah. So yes. So once you see it, you see an option of like how you can fork the repo. So once you have that, you fork the repo, so you have like an independent copy of that repo, and you can make any changes as you want. So because it's kind of easy way to go so that we can see your work. So once you fork the repo, so what will happen is you clone it to your local like directory or your local machine. So that's if you understand like how the GitHub works. So it will help you at the end of the day, because let's say you come to do your project, it will likely be collaborative. And once you're collaborating with your colleagues, you will need a meaningful tool so that everyone will be able to work together. So once you clone the repo, then you navigate to where the exercise submissions is. So once you navigate to it, which is here, let's say part 1 of this, then you go to exercise submissions, and you can see like the submission templates, or rather, yes, yeah, rather here you see like the week 1 exercises. So ideally, that's what you should do. Then you can see a link to the exercises, and you answer the questions and make your submission. So answer the questions, then make changes, which is your solution, then push to the fork repo. Then the link you send to us will be a link of your solution of the fork repo, which would be like something of this nature here, as you can see at the top of my screen here. And you send that via the Google Forms link. So we see that, then we grade you based on that. So that's the link you shared. So ideally, that's how it should happen. But if in the case this is much more of a complex task for you for now, so what you can do is either you can share this link with us. So let's say you are using Colab, so you can like run your code on Colab or your local machine, then you can easily share the link with us. And once we have the link, and make sure we can also access it, then you can use the link instead of your GitHub link. So that's one way to go. So, or rather you run it on your computer, then probably store the file somewhere, either your drive, then you send the link of the stored file to us. So that's one way. In the worst case, that's one way to go about it. But in the best case, so that it will help us, and also it will be beneficial to you to use GitHub, because it serves as some kind of portfolio. Anyone comes to see your project, hey, what's Mustafa doing? And he sees, he's been doing this deep learning course, and he can see you have like skills of using PyTorch. So that's what we would advise. But in the worst case, you can do that. So, but just let me know, do you need a session to show you how to like fork the repo, create, even though I guess there's a GitHub link that's been sent, you need a specific session on the assignment submission? Just can briefly type on the chat what if it's something you want. So there is yes. Let me see, any other yes? You need a session about like assignment submission? There's another yes, more yes, 20 yeses. Yes. So, okay, so look into how we'll coordinate with our colleague, maybe just briefly do a video of how the assignment submission will work, so that we'll share it also on YouTube. So you don't need to attend that, so it will be something offline, so you can attend it afterwards. So there's a quick question from Farouk before we round up. So if we submitted our assignment by creating a new repo, we have forked and submitted. Yeah, if you've submitted, no worries. So, but if you submitted, no worries, we'll evaluate that. But if you can do it in the format I explained here, so please do that so that in the subsequent case, but if you submitted, no need to resubmit at the end of the day. Thank you so much. So, yes, so there's a comment from caller about assignment question. Yeah, no worries. I think with when you look at the video, you have a better explanation. Yeah. So thanks so much for staying back. It's really nice talking to you. So it's good that at the end of the day, you've understood hopefully you've understood how PyTorch workflow works. And in your assignment, it will able to reflect that and also help you at the end of the day. So thank you so much. I hope you enjoy the rest of your weekend, inshallah. But feel free to send messages on Discord. Happy to hear any comments or suggestions or feedback at the end of the day. If there's anything, just let me know. So there is a comment on, can we know our assignments were graded? Yeah, we will send you a feedback about your assignments at the end of the day. Thank you so much. Yeah, so thank you. So finally, please, one more thing. So here, please check your emails as much as possible. Then there's a Discord link. We will send you an email of the Discord link so that you can look at them. So everything or any other additional information by the end of tomorrow or by Monday, you will receive it. Like the Discord link, everything, probably the videos might be midweek. Then also then the week 2 exercises, everything will be updated on the repository. So always check the repository. If there's anything you need or want, join the Discord as much as possible. Then I'll just send a Discord link. Let me see if I can get the Discord link and send it to you here on the chat. And just give me 1 minute. Yes, I'm just pasting the Discord link now. So feel free to message. So our TAs are very helpful and willing to engage with you anytime. So this is the Discord link. Please join. It's very important. So we'll send emails. So in case you miss any emails or you don't get emails, check your spam. It's very important. Then Discord, that's where you have engaging discussion, which has been happening lately by most of your colleagues, where you have several problem solving you encounter at the end of the day. Yeah, so it's really nice meeting you. I hope you enjoy the rest of your weekend. Looking forward to seeing you next week and also checking out your submissions. Bye. Yeah, you're welcome.